combined trigonometric functions today. So we are going to be looking at how we graph our functions and how we use our amplitude, period, maximum, minima, and asymptote. So finding our range, and we're also looking at how our transformations from last topic come into play with sketching trig functions. So you guys have all had the opportunity to have a go at practicing sketching y equals sine x, y equals cos x, y equals tan x. Now our y equals sine x, it always starts at 0 and then goes up. So it goes up to 1 at pi on 2, back down to 0 at pi, down to -1 at pi on 2, and back to 0 at 2 pi. At 2 pi is where it starts to repeat itself, because if we were to continue this on outside of our domain of 0 to 2 pi, it would go up again and it would give us this first part of our function. Okay, so that's what it means by repeating itself and the period. We then have our cos function. Our cos function starts at 1 and it goes down. So it goes down to 0 at pi on 2, -1 at pi, 0 at 3 pi on 2, and up to 1 at 2 pi. And we sketch a nice smooth curve going through our function. Now, tan looks nothing like sine or cos. Okay, tan has asymptotes at our pi on 2 and our 3 pi on 2. We then have cubics occurring between our asymptotes at the x-intercepts of 0, pi, and 2 pi. And with our tan function, it has a period of pi because this part starts again at pi. Does that make sense? So that's why it has a period of pi. The other two have a period of 2 pi. Now, we're looking at our properties of trig functions. You touched on these a little bit last lesson, but what we have is our period is the length of one cycle on the x-axis before the function repeats itself, such as 2 pi. Okay, so our period relates to our a value of our function. So it's our horizontal dilation. Our centre of a periodic function is the point that is equidistant from the maximum and minimum values. So for all our parent graphs, they all have a centre of 0. So we're shifting our graph vertically with our centre. So that means we are looking at our vertical translation. Our amplitude is our k value, and it's the height from the centre of the periodic function to the maximum or the minimum values. So it's very easy to do when we're just affecting the amplitude of sine and cos, okay, if it has a centre of 0, because we're just making that one value, or -1, multiplying it by that k value, okay. Tan has no amplitude because of our range of tan is -infinity to infinity. Okay, so it goes on forever. It does make the graph skinnier or wider, but it doesn't affect the amplitude. And then our phase shift is probably the hardest one to do, is how the function moves from the left to the right. Okay, if b is greater than 0, it shifts to the left. If b is less than 0, it shifts to the right. So it's exactly the same as how we did it when we were looking at our transformations. So we have the period and amplitude of general trigonometric functions broken down here. So we have our amplitude is always that k value out the front. So our amplitude is our k value. And we also have that our period is our a value in our functions, where period for sine and cos is 2 pi on a, like we discussed, but period for tan is pi on a. Then with our phase shift is our b value. Okay, so if we're adding, we are moving to the left, and if we are minusing, we're moving to the right, and then we have our centre is our value at the end. So just like how when we looked at our transformations, when we looked at our transformations of functions, we had it in the form of y equals k f of a of x plus b plus C. That's the same thing that is going on here, but instead of our F stands for function, so we're just putting in our sine, cos, and tan into these. So our general trig function for sine is y equals k sine A lots of x plus b plus c. For cos, it's y equals k cos A lots of x plus b plus c. And for tan, it's y equals k tan A lots of x plus b plus c. Okay, that's where, remember, our k is our amplitude. Okay, and we have no amplitude for tan. We have our A value helps us find our period. We have our B value helps with our phase shift. And we have our C value in each of these, helps us with our centre. Okay, flip the page for me because we have the next bit of information, or the examples for this lesson actually. So what we will be doing in this lesson, boys, is we have the functions and we are going to write them in the forms to start off with, and then we're going to identify our amplitude, our period, our phase, and our centre, and then we're going to give it a little sketch. So for the first one, we have the function y equals 3 cos 2 lots of x minus pi plus 1. Now, what we want it in the form of is y equals 3. So our 3 is going to be our k value. Then we'll have our cos, lots of. Now, we need to factorise out that 2, okay? We don't want something attached to our x. So we're going to have our 2 factorised out, leaving us with an x minus. Now, what we need to do is we need to work out what do we multiply 2 by to get pi. So what is the opposite of multiplying by 2? It's dividing by 2. So we need to divide our pi by 2 to get pi on 2 inside our bracket. And then we have our plus 1. So that is what happens when we factorise out our 2. So from there, we can now clearly see what our A, B, C values are, and our K value, and that will help us to then work out what our amplitude, period, phase, and centre is. So our amplitude is just our K value. So our K value in this case is 3, so that means we have an amplitude of 3. We have that our period, this is a cos function. So with cos, our period is 2 pi on A. So we have that it is equal to 2 pi over 2, which is just equal to pi because our A value was that 2. Our phase is that B is equal to minus pi on 2. So we don't just write that it equals minus pi on 2. We want to say that we're moving our graph pi on 2 units. Now, if it's negative, it means to the right. And then our centre is just 1. So we are going to shift 1 unit up. So from this, we now want to use that information to help us sketch our function from 0 to 2 pi. So what we have is that our period is pi. So we want to be able to fit our first lot of our graph, one go of our graph, between 0 and pi, but we also have that phase shift, which we're moving our original graph pi on 2 units to the right. So our amplitude and our centre are what we're going to have to look at for our graph. Our centre is 1. So our centre is going to be at 1. And I'm fairly sure when I did this yesterday, I drew like a line at our y equals 1. That's like our new x-axis, okay, where all the points are going to go through. Then what we need to do from our centre line, we need to add 3. And we need to minus 3 to find our maximum and minimum values. So if we add 3 to 1, we get 4. So our maximum value is going to be at 4. And if we minus 3 from 1, we're going to get our minimum values, are at Stay still. -2. Good, we can see all this. Okay. That's our first bit. Now, what we're going to have is we're moving our cos graph pi on 2 units to the right. It's a lot easier when we're moving something to the right, because what we will do is our graph will start up the top. Generally, for a cos graph, it starts at our maximum point, but we're going to move that pi on 2 units to the right, so it's really going to start up the top there. Okay, what we need is our graph to repeat itself, okay, within pi. Now, I believe in last lesson I told you how to work out what your axis should be with a changed period is you divide by 4. So pi divided by 4 means we want increments of pi on 4, and this is not the best axis for it, so we should have a pi on 4 there and a 3 pi on 4 there. We'll also, if we're looking in between pi and 2 pi, we'll have 5 pi on 4 and we'll have 7 pi on 4. So all of our odd numbers between 0 and 8 go on the top. So from here, we want to draw our cos function. So we're starting up the top here at pi on 2 because we've shifted our graph. We want to go down at 3 pi and 4 and, not there, we want to be on our centre line. So at 3 pi and 4 on our centre line, we want to connect. And then at our minimum value at pi, we want to connect. And then we need to do the same but going back the other way, because at 4, it's at a peak, it's at the very top. So at pi on 4, it's going to be at our centre line, and then it will be at our minimum where it originally starts. So our cos graph will look like this in our first part of it. Now what we have to do is just repeat this curve so that we have 2 repeats for it. So when we have our A value is 2, that means we're repeating our curve 2 times. That's going to help us when we solve equations next lesson. So we just want to copy what we have done and put in our dots and draw our curve from from pi to 2 pi. I need to fix it up. Going through those key points. Okay? And then that is our curve y equals 3 cos 2x minus pi plus 1. Does that make sense? Does anyone have any questions? Because you're going to do 2 by yourself. I'm going to step you through it. If you feel like you can do 2 by yourself, start having a go. What you do need to change is I forgot to change that you want to write in the form of y equals k sine. This one's a sine function for 2, so you can fix that up. I'll give you about a minute and then I'll start talking through it. So the first thing you want to do is factorise out your A value and write it in the form of y equals k sine bracket A lots of x plus b plus c. So if you're pulling out a 3 there, you need to divide pi on 2 by 3. What's pi on 2 divided by 3 going to be? 1/6. Great job. Okay, work out what your amplitude is. Your amplitude is your k value. Work out your period using your A. It's sine, so sine has a period of 2 pi on A still. Work out what you're going to write for your phase shift. and then work out what you're going to write for your center. So center and phase shift need some words with it, not just the value. Period is 2 pi and 3. 2 pi and 3. Great. I just wanted to double check. Okay, how are we going at identifying our amplitude, period, phase, and center? Good. Okay, hopefully you've got that your amplitude is 2. Your period should be 2 pi on 3. Your phase, your B value was pi on 6 and it was positive. So that's pi on 6 units to the left. And your center is -2, so it's 2 units down. Did we all get those? Okay, center's probably the easiest one to put on. So at -2, you want to draw a line y equals -2. All right, you don't want it to be like, if you're using a pencil or a different color pen probably, is ideal for this. Okay, if our amplitude is then 2, we want to go up 2 units to 0. So 0 is going to be where our maximum occurs, and down 2 units to -4. So we're only going to be working below that, what's it called? X-axis. Now, because our period is 2 pi on 3, so we have a period of 2 pi on 3, to work out our X axis increments, I don't know how to spell that properly. What you want to do is go 2 pi on 3 divided by 4, which is pi on 6. So this graph is perfect for it, because what we'll have is this is where pi on 6 is. This here is pi on 3, or 2 pi on 6 works out to be pi on 3. Then pi on 2 is 3 pi on 6, which simplifies to pi on 2. And then we have 2 pi on 3, and we'll have 5 pi on 6. Now, we had our A value is 3, so we are going to have our graph repeat 3 times. So there's the first time, and there's our second time. Okay, you don't have to, you can just keep it as the increments between, like where pi on 2 is pi, 3 pi on 2, and 2 pi is. You don't have to add on pi on 6, 3 pi, pi on 3, sorry, 2 pi on 3. That can just be there to help you out. Okay, now this is where it gets tricky, is that phase shift. So we're moving pi on 6 units to the left. So this is where, when we're moving it to the left, we have to imagine there's something on the other side of our y-axis. So that means our graph for sine normally starts at our origin. Okay, so it starts at our center. So at where negative pi on 6 is where our graph would start. Does that make sense? On the origin, it would start like there. So what happens is it goes up. So we're actually technically going to start up there at 0. At pi on 6 will be at our center. Pi on 3 will be at our minimum. Pi on 2, we're at our center. And 2 pi on 3, we're back at our maximum. So we have, does that make sense how we've shifted our graph pi on 6 units to the left with that dot? So then we just want to draw that bit in there. Ta-da! And then we just continue that wave going on. So then we go down, down, up, up, down, down, up, up, and put our dots. And draw a nice, smooth curve. Ta-da! And that is our y equals 2 sine 3x plus pi on 2 minus 2. Oh my God, we still have so many questions to do. Is that making sense, more sense compared to what you did yesterday? Yeah, a little bit. Okay.
Why can't we just use degrees?
Because we can use degrees, but we also can be asked to draw in radians. Now, I feel like in degrees, you're more used to using degrees, so that's why we're practicing more in radians. Okay? You have to make sure that you're reading the question to know what you're doing. All right, am I cool to scroll? Yeah? Okay, the next one. It's actually quite simple, these next two, because they're not as intense as the other ones. If we want to sketch the graph of y equals negative sine x in the domain of 0 to 2 pi, what does that negative do? It means our k value is -1, and it reflects in which axis? In our x-axis. Okay, so if we put our 1 and our -1 on our axes, I just like to pick 3 values up, 3 values down. You can pick 2. I feel like if you pick 1 square up, it's a little bit tiny. It doesn't look cool. All right, so our sine graph. Where does sine normally start? 0 or 1? 0. Good job. So normally we go up for our sine curve and then we come down. So we're going to do the opposite. We're going to go down first for our sine curve and then go up. I should have put dots. I really should have put dots. Like so. Does that make sense? I'm going to redo that because that's annoying me. So we go down first, down, up, up. So we do the opposite of what we would do. I think yesterday you had to sketch the reflection of cos, didn't you, in the exercise? So for cos, it would have started down here and gone like that, right? That would have been cos. Okay, if we are now going to have a look at any questions for A? No? So that's y equals negative sine x. Okay, if we're going to now sketch y equals 3 sine x plus 1, okay, what does that 3 tell me? It tells us our amplitude, or k equals 3. And what does that plus 1 tell us? The centre is c equals 1, so 1 unit up. So we're going to draw a line at where 1 is, where true 1 is. C equals 1, y equals 1. Okay, and then how do I find my maximum and my minimum points? I'm going to add 3 to my centre and I'm going to minus 3. So when I add 3 to my centre, I get 4. And when I minus 3, I get minus 2. Okay, sine. Where does sine start? The centre or at 1? Sine starts at the centre. Sine, centre, that doesn't make sense probably. So we start at centre at 1. We go up, down, down, back to centre. To start it all again. Nice smooth curve. Y equals 3 sine x plus 1. Sorry. Okay, 2 more examples to do. So, example 4, we now want to sketch the graph of y equals 5 cos 2x in the domain of 0 to 2 pi. So our 5 is our amplitude. So our amplitude is k equals 5. Our period is equal to 2 pi on A, it's cos. So it's equal to 2 pi on 2, which equals pi. Now, what does that 2 tell us? That 2 tells us that we have 2 repeats. Okay, so that means we want our graph to repeat itself twice. Okay, our x increments. How we work that out is our period divided by 4. So that is pi divided by 4. So we are going to, which is pi on 4. So we want to go across pi on 4 units. So sometimes you won't get given this graph. You'll have to do it yourself, okay? I think I've been quite nice and generous in giving you the graph. So we'll have pi on 4, 3 pi on 4, 5 pi on 4, and 7 pi on 4. All right, we're repeating at pi, so we're going to draw a little line there just so that we know. We're going up to 5. Now, this only goes up 4, so we're just going to say that 5 is where we want to be. Okay, our axes don't have to be great, or like as long as it's in proportion to each other. Now, it's cos. Does cos normally start at 0 or 1? 1. So that means we're going to start at our maximum value, and then we get to our center. So cos starts at the top, and then it goes down, down, up, up. Down, down, up, up. Cos is like coals, right? Down, down, the prices are down. That's how you can remember it, maybe. I don't know, I'm trying to think of ways for you. All right, a nice smooth curve. Y equals 5 cos 2x. Oh, I don't like this question. Where did this question come from? All right, looking at the last one here. So, pardon? Oh, we were meant to state the range. Goodness gracious. I haven't left enough lines, have I? So back to 4, the range is just -5 to 5. Good pick up. I was stressing about the next question too much. Okay, moving on to 5. Now, we have the domain and range of y equals cos x on 2 plus 1 minus 2. So our domain of any trig function is always going to be, unless we're told what the domain is and restricted to our domain is going to be -infinity to infinity, okay? Our function is periodic. It goes on forever and ever and ever. Now, what we need to identify is for our range, we need to know our y transformations. So our y transformations are our amplitude and our center. So what we'll have is that our amplitude is equal to 5 and our center is equal to -2. So what that means is that for our range, how we work it out is our range will be our center. It'll be our center minus our amplitude. and it will then be our center plus our amplitude. Does that make sense? So in this case, our range should have I should have done a higher upper line, sorry. So in this case, our center is going to be -2, -5. And it will be -2 plus 5. So therefore, our range is going to be -7, 3.